Hello and welcome to day one of daily Leetcode challenges. I took a little break, getting back into it. Also lost my streak, but hoping to get that back and beat the 34 or I believe 35 record that I had last time. So let's go. Okay. Question number 427. Construct a quad tree. Given an n by n matrix grid of zeros and ones only, we want to represent a grid with a quad tree. Okay, you want to represent an n by n matrix as a quad tree. Return the root of the quad tree representing the grid. Notice that you can assign the value of a node to true or false when isLeaf is false. Okay, so actually let's look at the node first. The node consists of the value, so either the value, either true or false, isLeaf, either true or false, node top left, top right, bottom left, bottom right of type node. Okay, so notice that you can assign a value of a node true or false when isLeaf is false, and both are acceptable in the answer. Notice that you can assign the value of a node to true or false when isLeaf is false. So it doesn't matter if true or false, it doesn't matter what value is when isLeaf is false. Okay. Quad tree is a tree data structure in which each internal node has exactly 4 children. Besides, each node has 2 values, val and isLeaf. Okay, so true if the node represents a grid of ones or false. Oh, true if the node represents a grid of ones, or false if a node represents a grid of zeros. isLeaf true if a node is the leaf node on the tree, or false if the node has 4 children. Okay, so starting to make a little bit more sense. It seems like only the leaves are there to represent actual data. The non-leaves are just sort of organizational nodes. So we can construct a quad tree from 2-dimensional area using the following steps. If the current grid has the same value, i.e. ones or zeros, set isLeaf true and set value to the value of the grid. Oh, so if the current grid has all the same values, set isLeaf true and set val to the value of the grid. Okay, so basically joining all these 4 to 1. So if this is 1, if this is 1, if this is 1, if this is 1, this top left is going to be turned into a leaf of value type 1. If the current grid has different values, set isLeaf to false and set the set the value to any value and divide the current grid into 4 subgrids as shown in the photo. Okay, I think I'm starting to understand the idea. The idea is to represent a grid of ones and zeros unless in less information than just an n by n matrix, sort of like compression. The way that this compression works is that there's a node type. Node type can serve 2 purposes, either representing a leaf, which tells you which value that node has, or it can represent a positional node. The positional node simply tells you which of the 4 areas to dive into. So actually, let's just start implementing this and see where this takes us. Uh, Off the bat, I can say that if we've reached the end of the if we've reached the end of one of these grids, if our grid is of length 1, meaning that we have reached the end, there's no more division possible, then we can simply return a node where the value is going to be true or false depending on the grid's value. So I'm going to say grid 0, 0, let's say true if 0 is equal to 1, else false. And let's see, is leaf, that is going to be a true, and none, none, none. Sweet. So this is the case where we have reached the bottommost grid. There's no more divisions possible. So we do this then. Let's half our length by 2. What if there's a odd amount? What if n is always a sum power of 2, so that's not possible. It's always going to be divisible by 2. We divide length into 2, and then we should say, let's start constructing our node, the node that we actually care about, the current node, in the case where we're not a leaf node. If we're not a leaf node, then our node has to have a top left, a top right, a bottom left, and a bottom right. So, I mean, the return here is going to be some value, doesn't matter, true. Actually, let's just call it none. This is definitely going to be false. And top left, top right, bottom left, bottom right. Okay. Top left, node, and let's have 4 more. Top right, bottom right, top left, top right, top left, top right, bottom BL, BR. Okay, BL, BR. In the node here, since we are constructing, we're going to, oh shoot, no. Since we're returning the node from the subsequent call, we're actually going to say self-construct. Okay, so we're going to be constructing subsequent nodes. How are we going to figure out what to well, first of all, the grid has to be divided to top left. It's going to be the top left grid. So let's actually what I really want is I want the grid, and then I want the first half, and then also half. What I'm doing here is just passing to it sort of the top, first of all, the top left. So I'm choosing the first half out of my n by, I'm omitting the second half of the arrays and omitting the second half of the innermost arrays. then I'm going to omit, I'm going to keep this, and I'm going to omit the next part of the arrays. Then here I'm going to be looking at I'm going to be omitting the first part of the arrays, and then taking the first values from the arrays, and here I'm going to be omitting the first part of the arrays, and then also omitting the first part of the values. So this should be it. And is this it? No, this is not it. Grid. So, okay, one theory I have is I might be not using this correctly. I want to see if I can print a grid with the way that I want it. So I'm going to say 2, and then also another 2. Submit. Let's see if we were getting actually what we want. Okay, let's do half of it's L of grid. Should be 1, so we should get one value here. And SC out, sorry, divided by 2. Okay, so that might, I had a suspicion that maybe this wasn't working. It probably, for nested arrays or two-dimensional arrays, this might not actually work. Because it is sort of like I have to apply this split feature to each of the subsequent arrays, which this is probably not doing. So let's actually take a step back and say that instead of doing it like this, we're going to initially divide, let's divide it into the left and the right half. The left and the right half, what would that look like? Left and the right half would be grid half for array half for array in grid. And for the right, we're going to do the same thing, except we're going to be omitting the first half of all the arrays. Okay, and then left, top left is going to be left, and this is going to be omitting the, and for the right ones, bottom, no, sorry, I messed up. For the right, I have to omit the first half, so half and onwards, left, bottom left is going to be omitting the first half, bottom right is going to be like this. Sweet, okay. Wrong answer. Input, output expected. So what am I, is this even remotely? Oh, I completely forgot about that. This is the full representation of the tree, so we don't actually need insane, we don't need full recursion down to the level, or actually no, we do. We need if, okay, so if the value of all the TL, TR, BL, BR nodes is the same, then we can conjoin it into one node, right? So if TL val and TR val and BL val and BR val If they're all the same, then return a node whose value is uh, true, who is a leaf node, and none, 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 none. And if not TL val or top left val or bottom left val or bottom right val, return node false, true, none, 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 none. Okay, sweet. Else return the do also this if should they all be leaf nodes also? If TL is leaf and TR is leaf and is leaf and BR is leaf. What am I doing wrong? True. Okay, let's think through this one more time. I am looking at a full array. How am I going to start the initial divide? The initial divide, I want to divide the square into four equal parts. That's going to be my half, and I'm going to divide it into four equal parts, and I'm going to return a node where my value doesn't matter which one it is, because I'm not a leaf node, and my top left, top right, bottom left, bottom right are here. Now, how do I get my bottom left, bottom right, and so on? Well, one thing that I have to worry about is if I am a... How do I have to worry about bottom left, bottom right? How do I construct it? Well, I construct it recursively. I give to my top left a grid that I've divided. I give to my top left the grid that I divided. Starting at any point and ending at the half. The right grid divide is array grid. I start at half and go on to infinity and go on to the end of the array, which is all fine. I should be dividing these correctly, and then I'm passing them down left, and I do, since it's left top means that I take the first half. Right top, bottom left, bottom right. There we go. Sweet. Okay. Yep, that's what we wanted. Let's see what we have here. Some better solutions. Pretty intuitive, right? The reason why we needed this is because if we don't have if we're not a leaf node, then there could still be an instance where we yeah, if we're not a leaf node, then what would prevent us from having a uh and why did this make sense to me when I first heard it? This makes sense. This is the compression portion. I'm compressing four nodes into one essentially by saying that I am a leaf node. And oh, the reason I need this is because when I return, okay, I got it. Because non-leaf nodes also have the value, because non-leaf nodes also have value, I only look basically the first, because non-leaf nodes also have value, this value has to be initially ignored when looking at this compression. The only time where I can compress is when I'm certain that the node is actually representing a value rather than just having a placeholder, in which case this is. So this portion right here is meant to only look at nodes that actually hold real values, which are leaf nodes. So um, make sure that the node is a real node, looking at a real value. Make sure that a node has a real value, and then make the compression. Otherwise, this true would have been picked up by this compressing it portion, and we would have been screwed. So in terms of speed, let's see, we're running, I mean, I don't think we're running too much behind, so um, yeah, I would say that this is a good solution. Um, Thanks for watching.